Hi, good morning.
Good morning, sir.
Please give me a moment. Thanks for having me. Okay, so I'm just trying to switch my windows around. Give me a moment. So I think you are able to see my screen, right? Okay, so let me move forward. So again, thanks PST ECS for organizing this event, and thanks everyone for having me. My name is Sei Guan and I'm from Singapore. I'm sales engineer covering the whole of Southeast Asia. So my topic for today is hybrid cloud management with Kubernetes and Venture. So let me move on. The agenda for today, I will first start with the overview of SUSE. So briefly talk about who SUSE is, give some background and history on SUSE. Then I'll move on to cloud native
Hi, sir.
trends.
Sorry to cut you off.
Hmm?
If you could just change your setting. You are what we are viewing now is you are on a presenter view.
Okay.
Yeah.
Wow,
So we are able to see your notes as well.
that is weird.
Yes. Yeah, that's perfect. Thank you.
Now okay.
Yes.
Oh, that's okay. Give me a moment. Because in this way, I won't be able to see my
See
own
your
notes.
screen.
Yeah,
Okay.
so, okay, give me a moment. Okay, I'm not too familiar with Zoom, so, okay, probably let me reshare my screen again. It's weird. It's just to, share notes. Okay, if I share this, so can you see just the PowerPoint itself, or are you seeing both the presented notes again?
This is better. Yes. This is now
Oh, you are
okay.
just
Yep.
seeing the
Oh
PowerPoint, right?
no, but we are still seeing the what do you call that? Your notes.
Okay, I need to switch the screen around, so give me a moment. I don't know why it always go to the wrong screen, so give me a moment.
Ano? Can you snip na lang? Yeah.
Okay, sorry. That's pretty weird. So in this case, I might need to switch. That's pretty weird.
With this view, are you able to see your notes?
I am unable to see my notes at the moment, so I
Oh,
need to switch it around a little bit.
all
So
right.
give me a moment.
Okay, if you could just please snip the portion of the presentation that you want to share. Uh,
Okay,
yeah. You can
so
actually just
now,
snip.
okay, I think are you just seeing the right screen now? Okay, so
Uh, we can't see any. It's just black and
it's
your
just black.
video. Yeah, it's just black. I think you snipped a wrong portion. Can you please go back? Share screen, sir. Okay. And then you go to advance
Sorry, let me
there.
share screen
Okay, you go to
and
advance.
advance. Oh, okay.
And then a portion of your presentation. So just snip that
I see.
PowerPoint slide.
Okay, I have switched my screen around a little bit, so probably let me try again. Now are you able to see my screen?
Yes,
Just
just
okay.
the opening
Oh, then
slide.
okay. Let me move. Are you still just seeing the screen now?
Yes, sir.
Okay, that's
All
good.
right. Thank you.
Okay, finally we get it working. So sorry for the
No, it's all right. It's all right.
delay.
No
So
problem. No problem. Thank you,
okay.
sir. Please go ahead.
Yep. So
Thank
the
you.
agenda for today is first I'm going to talk about SUSE overview. Then I'm going to talk about the cloud native trends. I'll discuss about some of the latest cloud native trends and some of the key underlying drivers. And then I'll move on to Rancher overview. Talk about how SUSE Rancher applications can modernize and accelerate IT infrastructure. So okay, so I first start off with SUSE overview. So SUSE has been around for 28 years. So we are one of the pioneers of the open source movement. Um, we started off in 1992 and we are the first company to bring enterprise Linux to the world. So after that, it has been, some of the important milestones that we have achieved along the way, such as joint innovation with SAP and stuff like this. Recently, there are more exciting happenings happen to SUSE. So first in 2019, we have a partnership with EQT, a private equity company. And then in 2020, we acquired Venture Lab. And just a few weeks ago, we are listed in the Frankfurt Stock Exchange. So exciting changes are coming to SUSE, and we are definitely going to grow bigger and stronger and going to serve customer better and better. So over these 28 years, we have a lot of successful and satisfied customer. So some of the key highlights are 80% of Linux, 80% of large enterprises are using SUSE Linux, and 80% of Linux for SAP, they are using SUSE as well. So these are some of the key highlights. So I just want to highlight a bit about Rancher. So Rancher is the most widely adopted enterprise Kubernetes management platform in the world right now, with 100 million plus downloads, 35,000 plus active deployments, and 400 plus enterprise customers. So it has achieved broad industry adoption. So as you can see from here, these are some of the logos that we have. And we also have partnership with many of the CSP and IHV. So according to Forrester, Rancher is now a new wave dealer. So you can see from the quadrant, Rancher is in the leading quadrant, as you can see from here. So open source is becoming the backbone for driving digital information, according to Gartner in 2019. So definitely, I think more and more enterprises will be embracing open source more and more. And open source is really becoming the industry standard going forward. So just want to highlight, the portfolio of SUSE. At the bottom, this is just the cloud infrastructure. It can be in hybrid or on-prem or in the cloud. But be it any kind of infrastructure, SUSE comes with a Linux distribution, which is the OS that's able to support all your workloads that's running on top of whichever infrastructure that you are running on top of. So this is the OS layer. We have a full portfolio of OS products that's meant for all kinds of use cases. And then we have something called SUSE Manager to manage all your Linux workload, including non-SUSE products such as Ubuntu or Debian or even Red Hat. So SUSE Manager can manage all your Linux workload in your infrastructure. So on top of that, we have the Kubernetes layer. This is the part that I'm going to cover today. So this layer, SUSE comes with, after SUSE acquire Rancher, we have the product that manage Kubernetes. So next, I'm going to talk about the cloud native trends. So what is cloud? To a certain extent, cloud is a word that has been overused over the years, right? So everybody is using and consuming clouds. So for example, when you are using your handphone or when you are, just watching IPTV, that kind of things, you are already consuming cloud. So what is cloud actually? Cloud are just services that can be accessed and delivered over the internet. So it can be, can be categorized into different kind of services. So I think you often heard of things like SaaS, software as a service, or platform as a service, or infrastructure as a service, etc. So all these are considered to be, cloud, and these are meant to be consumed. So since cloud can be so easily consumed, now it gives rise to more and more adoption of cloud. So every enterprises, every industry are making use of cloud in one form or another. And most forward-looking company are creating their own cloud ecosystem by placing their customer in the center. So as you can see from this diagram over here, they put customer in the center, and they are developing all kinds of ecosystem around the customer. So this is basically the trend right now, and any customer can be, and I mean, any consumer of cloud can be anybody. It can be an end user, it can be a customer, it can be an employee. So it can be anyone within the ecosystem who consume cloud. So in other words, cloud is now becoming an integral part of any individual and any enterprise. And I feel the whole process has only get started. So next, I'm going to talk about cloud native. So cloud native is an approach to build and run application that exploits the advantages of cloud computing. So simply put, cloud computing is the delivery of any computing services over the cloud. So for cloud native to be successful, over the years, infrastructure and applications has also evolved massively. So what happened is, as you can see from here, this diagram over here, it just breaks down the IT landscaping into various pie. So firstly, let me talk about application design. So over the years, the design of application has changed. So I think initially most of the application are based on monolithic design, whereby it is one code, and the code gets bigger and bigger. And it's to a certain extent, developing code based on monolithic design has its merits. But over the years, because the code, when you add more and more feature onto the code just get bigger and bigger. And to a certain extent, it's going to be more and more complex. It's harder to modify. And until a point whereby it's even very difficult to do a restart of the code itself. So it slows down development, and it becomes hard to manage, hard to release, and even hard to patch. So there's so many security concerns nowadays, right? So imagine your application is very hard to patch. You might find it very difficult to find a downtime to shut off the to shut off the application in order to enable patching. So definitely, I think a new approach is needed. So here comes microservices. So microservices is basically splitting applications into smaller sets of interconnected services. So services typically implement a set of distinct feature and functionality. So for example, if you are developing an online store, you can have a service or app solely for order management, or solely for payment, or solely for customer management, etc. So, and then you build all these different small modules together into one app. So in this way, you are basically you are putting your application into modularization, so that's easier to manage. So for every single module, you don't need to stick to, you can use the code or the languages or the framework that is most suitable for the particular module, rather than, in a monolithic design, you need to choose a code that is meant for the whole application. Now you can break the application up into smaller parts and then choose what is best for that particular application. So to a certain extent, it becomes easier to understand and easier to develop and test. So developers don't need to go into the whole chunk of code and then do modification from there. They can just go to a single service and single module, and then just do any modification from there. So next, I'm going to talk about development style. So because of the new application design, there's a need to develop application. There's a need for a new development style so the applications can be developed faster. Because now with the new modular design, codes are getting smaller and more efficient, and hence can be developed faster. In this way, the previous design, which is called the waterfall design, is meant for those monolithic application, whereby it's a one-way flow of development to production. So the code is there will be addition to the code will be development, then it goes to testing, then finally go to production. So every cycle is going to take a long time, probably even up to a year. So with the proliferation of microservices, there's a need for a more streamlined development style. So here comes the CI/CD style, whereby small parts of applications can be continuously released all the time. And because of this, right, since application can be developed so fast, there's a need for the application team and the IT team to work hand in hand together. So with that, there comes a new ideology or philosophy called DevOps, whereby the IT team, whereby the IT ops team and the application teams come together, and there's no distinction between the IT team, IT ops team, and the application team anymore. So previously, developer, they only write codes, whereas the IT operation team will provide infrastructure and then deploy the code. Now, this line is getting increasingly blurred because developer with new technologies coming in, a developer can deploy IT infrastructure easily as well. So at the heart of the whole evolution, there's a need for infrastructure to be evolved as well. So the new infrastructure whereby applications is building on top of must be able to enable automation, scalability, portability, and predictability. So this is where container come into play. So basically containers are just Linux processes which mount a separate disk image by making use of Linux features such as C group and namespaces. So C group provide assignment of resources to processes, whereas namespace provide isolation of processes, so that one group of process won't be able to see or access another group of processes. So the old way of application delivery is basically putting on top of either bare metal, whereby you install OS and then on top of just on top of the server, and then deploy your application on top of the OS, or you can have a hypervisor layer such as VMware, and then from a number of physical servers, you install the hypervisor, and then you can launch your application on top of the hypervisor. But both the ways are not as efficient as containers because there's a lot of overhead involved, such as the OS. Whereas for container, as you can see from the diagram over here, you just need to have a server and has the OS kernel running, and then has a container runtime such as Docker or Containerd running, and then you can launch many containers on top of this infrastructure. So meaning that all these containers, they are sharing the underlying resources rather than each of them having their own resource and incurring overheads. So because of these, containers are lightweight and efficient, easy to create, deploy and scale. They are consistent and portable. So meaning that the same code can be run and deployed everywhere. And at the same time, it is easy for developer to create a package and then just with the software needed to run. So containers are now a critical IT property because of the ease to create container, and developers are getting more and more ready in using container as the main packager for application. So as you can see from this diagram over here, there are some numbers that I want to share with you. So from a visibility point of view, 60% of developers have used containers for software development, and containers are now a top priority for IT leaders. But only 10% of containers are currently containerized, which means that the opportunity is huge. And we are expecting there's the growth of containers of 50%, 50% new container adoption by the end of 2021. So the opportunity is huge, and the adoption of container is just started, and it's going to get more and more going forward. So because container is so easy to be used, to be consumed by developer and by enterprises, you'll reach a point whereby you have just simply too many containers to develop. So just assume that you are a developer. So every time you just launch a new container and then you make some changes on it, develop some codes on it. But after a while, you will find that you have many containers. And if you have many servers or VMs to manage, you might not even know where your containers are being hosted. So developer, they definitely need a better way to manage container. So because of this, there's something called Kubernetes. So Kubernetes was first created by Google. But in 2015, they donate Kubernetes to a newly formed foundation called CNCF, Cloud Native Computing Foundation, which is being run by Linux Foundation. So this made Kubernetes fully open source, meaning that it's vendor neutral, and no single vendor can claim ownership to Kubernetes. So in this way, end user is no longer locked down by any vendor. So as long as the Kubernetes version that they are using are CNCF certified, they are able to use any version that's out there. So assuming they are using one Kubernetes distribution, and after a while they might want to change to another one, they can just do that without much issues. So by out of the box, Kubernetes already come with all these features, all the features over here. So with this feature, it's already functional out of the box. So in fact, Kubernetes is not the only container orchestration and management platform out there in the market. There are also some other products such as Docker Swarm and Nomad. But now Kubernetes is the undisputed leader in this field. So just want to briefly touch on the Kubernetes architecture. So before I touch on the architecture itself, there's a new naming convention that I think I might need to share with you first. So we talk about containers, but in Kubernetes, the containers are being repackaged or abstracted as something called pods. So in under Kubernetes, containers are no longer run as container. They are now run as pods. So pod is basically just a single container or a group of tightly coupled containers. So the key thing to bear in mind for this Kubernetes architecture is it is divided into two separate components, as you can see over here. So the first component, normally we call it the Kubernetes master, or we can call it the master node. And the other component, we can call it the worker nodes. So the master node is the central control plane for Kubernetes to work their magic. So it consists of the API, whereby both internal and external requests got to go through the API. And then it consists of things like SCD that maintain the cluster integrity and the cluster status of the whole Kubernetes cluster. So what is going to happen is every time when a container or pod is being deployed, it will be deployed on the worker nodes. So this is just the brain behind the whole Kubernetes cluster, and then containers will be launched here. So these are the two distinctive components that make up Kubernetes architecture. So I've touched quite a fair bit about Kubernetes. So this is just a summary of the organization benefits that Kubernetes bring about. So it increased velocity, expand benefit, business benefit because of the way container is. Container is lightweight, it's easy to be used and consumed. And then with KAS, with Kubernetes, it ensures that containers can be managed and maintained and deployed in a very simple manner. So with Kubernetes, is just the way forward for organization. It's a necessary platform for organization to use in order for them to hop onto the digital transformation bandwagon. And it also avoid vendor lock-in, as it is now an open source project. So because of the way container is, it is lightweight. Again, it is lightweight, and it doesn't take up so much resource, meaning that you can pack more containers, or at the same time, meaning you can pack more applications into the same underlying hardware infrastructure. So meaning that you don't need to invest so much in hardware infrastructure, and so it reduces costs. So it also brings about a lot of user benefit. For example, it integrates with deployment system, because Kubernetes is driven by API, meaning that all your CI/CD tools or all your deployment tools and applications can integrate seamlessly and perform actions on both the clusters as well as the pods that's running within the cluster itself. So we like to say that applications running on top of Kubernetes are auto-healing, so it can recover from failures on its own. This is because Kubernetes run in a declarative way, meaning that you tell the cluster what state, you tell the cluster and the pod what state they want the pod to run. And then every time when a pod encounter failure, another pod will replace it automatically. So say assuming you want an application to run 3 instances. So something happened to one instance. Because it is called in a declarative way, another instance will be run automatically to ensure that at any point of time, 3 instances of the application is running. So the next thing is it can scale automatically. So with with everything going to the digital realm, so that there could be situation whereby your applications would require more bandwidth. So for example, you are running e-store, a e-shop, and then for the particular week you are running a promotion. So for the promotion, you're expecting your traffic to be ramped up probably 10 times, 20 times. If you are using traditional hardware, then it's going to be a bit problematic because it is difficult for you to just suddenly deploy so many hardware out of nowhere, or you might already need to purchase a lot of hardware to be readily available for you to be ready for that event, which is going to incur a lot of costs. So what Kubernetes can do is only for that event, you can scale the applications automatically in a manner whereby it might not be just running on top of your on-prem infrastructure. You can even scale it up to the cloud. So something called cloud bursting, in a way whereby you don't need to incur a lot of costs. You just need to scale accordingly over the certain period whereby you need to have more resources. So handling microservices, I think I talked about that just now already. So when we talk about Kubernetes, it actually comes with many favors. So Kubernetes, as I mentioned earlier on, is an open source project, meaning that you can deploy Kubernetes on your own. But what is going to happen is Kubernetes is not really that easy to manage or even build. So I've heard many feedbacks about Kubernetes. Even installing Kubernetes is going to be very painful because it involves a lot of dependencies and repository. So upgrading and updating Kubernetes is going to be another challenge as well because Kubernetes release a new version every 6 months or so. So definitely, if you want to have an easier time managing Kubernetes, you might need to turn to some products or some open source distribution. So for example, when it comes to open source distribution, you have Rancher, you have DCOS, or you have OKD. But the problem with all these open source distribution is you are unable to get support. So assuming you are launching applications on top of Kubernetes for production, for that kind of cases, you might need to, if something happened to your Kubernetes cluster, you might need to get support as soon as possible. So doing it the open source way might be not efficient enough. So every time you encounter issue, you might need to go to forum to search for, possible resolution, or you might need to go into troubleshoot every single, issues that you might face. So a better way to solve, to approach this whole issues or concerns is to go to the commercial model whereby all this vendor is going to provide support for the Kubernetes clusters that you're running your applications on top of. So when it comes to commercial products, you have a whole list of products over here. For example, Rancher, Red Hat, OpenShift, VMware Tanzu, and among others. So the key differentiator of Rancher is for the open source product as well as the commercial product, they are using the same product. So there's no difference whatsoever. So assuming that you are doing a lot of testing on Rancher, you are running a lot of testing applications on top of Rancher. And after doing your testing and development, you find that Rancher is a good platform to use and you want to move to the commercial product of Rancher and you want to get support for your cluster. You don't need to migrate your Kubernetes cluster and the applications on top of it from the open source version to the commercial version because it is exactly the same thing. So what you need to do is to just look for us, give us a call, write an email to us, and you can convert your open source version of Rancher from a testing environment to a production environment to get the support that's needed from Rancher. So the whole process is very seamless. And it's just, I feel this is, it just greatly enables organization to jump on top of using Kubernetes. So basically, Kubernetes address the needs of both developer and IT operators. So whichever Kubernetes distribution and management tool that you are using, it is supposed to work on any kind of infrastructure. So as you can see from this diagram over here, at the bottom, it's just any kind of infrastructure that you are running. There's a Kubernetes layer running on top of any infrastructure, and then you have the whole suite of features and functions that comes out of the box with Kubernetes, and which both developer and IT operators they can make use of it. So with this, I'm going to the next section of my presentation, which is talking about Rancher. So Rancher is, the name of the company itself that SUSE acquired. It also is also the name of our best-selling product called Rancher. So Rancher, what we like to call it is it's the most popular, Kubernetes management platform. So I talk more about Rancher later. So basically, under Rancher, under the company Rancher, we call it Rancher Labs also. Under Rancher Labs, we have a number of products and projects. So what's the difference between products and projects? Products are projects that we already make it commercially available, meaning that we provide support for it. Whereas for open source project, they are just a community version of the project itself, meaning that we do not sell any support for this project. So I'm not going to details here because I'm going to talk more about some of the Kubernetes products going now. So this is the Rancher open Kubernetes management platform. At the bottom, again, you have all the hardware infrastructure from data center to the cloud to the edge. And for every single hardware infrastructure or environment, you can run Kubernetes on top of it. So for Rancher, we have our own Kubernetes distribution. For data center, we have something called RKE. And for the edge, we have something called K3S. And again, for data center, you can use whichever Kubernetes distribution that you have. Similarly, for cloud, you have Amazon AKS, Azure AKS, and among others. So as long as any of the Kubernetes distribution that you're running is CNCF certified, Rancher is able to support it. So just now I mentioned that Kubernetes out of the box already come with many features and functions that make it easily consumable for both developer and IT operators. Rancher make that even, just expand all the functions and features and make it a full infrastructure kind of deployment. So it's a full, it comes with full suite of features and functions, and you can just make use of Rancher to do all sorts of infrastructure, operations and maneuvering that you want to do on top of the whole cluster. So what Rancher does is not only that, you also, as a single pane of glass, can be used to manage all your different Kubernetes cluster. So assuming you have 10 Kubernetes cluster running on-prem, another 10 running on the edge, another 20 running on public cloud. So with just a single Rancher server, you are able to manage all of them from a single pane of glass. So Rancher also support third-party services and components, because going forward in the open source world, more and more organizations, they are looking at making use of other kind of tools to integrate into their whole development process. So normally we call that the CI/CD pipeline to enable DevOps, so that development and operation can be linked together. So Rancher understand that, and Rancher doesn't want to lock down customer in the sense that they provide a certain suite of tools for customer to use. So they want customer to have their free will and free choice and choose whatever components that they wanted. So for example, some of the customers, they are already using certain components during their testing environment or development environment. So Rancher respect their decision to use all these components, and they don't want customer to use only components that Rancher provide. So in this way, rather than binding customer into a certain suite of product, Rancher provide certified integration. So as you can see from here, there's two main classification. So we provide Rancher SLA for all these products. So meaning that Every time you encounter issue, we will do break fix for you. We will do root cause analysis, and we will ensure and guarantee your issues are fixed. So for all these certified integrations, we'll ensure that these components run without any issue on top of Venture and on top of RKE and K3S. So assuming that any issues that you face with all these third-party components, you can just log a case with Venture, and we will make sure that we will find we'll do root cause analysis and ensure that this component is working fine with Venture. So assuming that the issue is found to be on the integration portion, Venture will fix it for you. But if it is found that the issue lies with the underlying component itself, then you might need to Venture will advise you the next step to do, and you might need to check with the component itself to see how you can fix the issue. So this is a high-level architecture of Venture. So as you can see from here, it consists again of two separate portions. First portion is the Venture server. So this is the chief, the single pane of glass whereby you can log in, you can do all kinds of infrastructure, operation on the Venture server itself. From there, you can use it to manage all your downstream, all your clusters that you want to manage. So normally we call this cluster the downstream clusters. So it can be just one cluster, it can be 10 clusters, it can be on-prem, again, on the cloud, on public cloud, on-prem or on the edge. So regardless of where the cluster is being deployed, Venture from a single server is able to see and talk and manage all these various clusters. So just want to show you, how does the Venture web GUI looks like. So it's a pretty clean design. You can see from here, you can just again, when you log into Venture, you can see all the clusters that you are managing, and then you can zoom into each and every single cluster and see, how much resource is being used, whether there's any events or any issues, and then you can further go into each clusters to check out the underlying specific. So for example, Kubernetes cluster, you make up of pods and namespaces and services, ingress, that kind of thing. So you can just go in here and then check out every single aspect of your cluster. And it's not just checking out every single aspect of the cluster. So one of the key problems of Kubernetes is, I think a lot of users find that it is hard to remember the commands. So Kubernetes out of the box is predominantly, command line. So you need to run commands such as qconfig, get pods, describe pods, that kind of things. So Venture extract away that layer. So you can make use of the web GUI to run. You can make use of the web GUI to just launch pods or services, whatever, rather than using command line. And you can do troubleshooting from there as well. So you can even go into each container in the form of shell to check out that whether there's any issue lying with the container itself. So again, just want to talk about the Venture unique approach. So the key thing right now is Kubernetes distribution are increasingly commoditized, meaning that there's no distinction between various Kubernetes distribution. So people no longer choose which distribution is better than the other one. So the value now is managing Kubernetes the cluster. So, and it's not just one single cluster. You are now, as Kubernetes become more and more popular, so similar to container. Initially, when container is being launched, people use it more and more, and they need Kubernetes to manage many containers. Now, the tide has changed to such an extent whereby people are having more and more Kubernetes clusters, and they need to have a management console to manage the multiple Kubernetes cluster that they have. And it's not just on a single environment. It can be on-prem, on the edge again. So you need to have a good management console to manage all your different Kubernetes cluster in all kinds of environment. And last but not least, again, we don't want to lock vendor down. We believe that the open approach is the best way going forward for customer to make full use of the infrastructure they have in hand. So just want to briefly talk about the other products that Venture has. So RKE, again, is a Venture Kubernetes distribution. So it is CNCF certified. And again, as I mentioned earlier on, Kubernetes is not that easy to deploy and not easy to do upgrade and updates. We take all these difficulties away from you by developing RKE. So again, it is free to use. You can just download RKE and test it out. So Longhorn provide persistent block storage to Kubernetes cluster. So containers might be, immutable, meaning that every time you launch a container, it is always in the same state, which means that normally you might not need to have storage, persistent storage attached to it. But then there might be some cases whereby you need to have persistent storage. For example, you need to have a database or you need to share some files. So over at Rancher, we provide something called Longhorn to enable customer who need that kind of usage. So to summarize, Rancher, the data center, you have the Rancher server, and you manage all kinds of downstream clusters. So the downstream cluster can be running on-prem on top of RKE, or can be on any other distribution. It can be on public cloud, running on AWS and Azure and that kind of things. So as long as any Kubernetes cluster, the Kubernetes cluster that you are running are CNCF certified, Rancher is able to manage it. So at the edge, we have K3S as well. So K3S is just a trimmed down Kubernetes distribution. So basically at the edge, right, your resources are limited, and normally you have just one single server. For normal Kubernetes distribution, as I mentioned earlier on, the Kubernetes architecture, you need to have master node and worker node. So in the production environment, you need to have at least 5 nodes. Whereas for the edge, 5 nodes can be a little bit of a luxury. So because of that, we Rancher come up with something called K3S, which is a fully functional CNCF Kubernetes distro. Doesn't require external dependencies, and it is just a low footprint, low memory and CPU footprint for you to deploy Kubernetes on the edge. So we have also something called Rancher Fleet. So for Rancher Fleet, it comes pre-built into Rancher server itself, so you don't need to pay any extra charges on it. So what happened is you have already too many clusters to manage. For example, you have thousands of clusters to manage. Even Rancher management server itself might not be an efficient way to do it. So Rancher acknowledges that, and it comes with something called Fleet, whereby it is making use of GitOps, which make use of GitHub. So every time you make any changes to GitHub, Rancher Fleet is able to detect the changes and then deploy the applications to specific clusters that you want it to be deployed on. So Rancher at the edge, you have the Rancher server, you have Fleet that's being built into Rancher server, and then you can deploy applications to practically anywhere. It can be, just a e-store or devices using IoT devices, and even automobile or planes. So as long as you have K3S running on top, you can use Rancher to manage all of them. So with this, I come to the summary, and the summary is, you can run Kubernetes everywhere with Rancher. And just one final slide. This is, a summary of what I have covered so far. I think I won't be going through that because my time is up. So this is the end of my presentation. So thanks everybody for going through with me on the Rancher products. And if you have any questions and if you want to know more about Rancher, please feel free to reach out to us. Thank you very much.